R2, exponents and scientific notation. Most of this is going to be review. Okay. This table is on page 21 in your book. It would probably be easier for you to screenshot it from your book and put it in, but it's also things that you should already know. So how much you want to do with that is up to you. I will quickly go through it. The bottom line is we're talking about situations where A and B are real number bases. Okay? So notice here I've got bases of B's, I've got a base of A, and then M and N are integers, and they are the powers. And so what they do is they give you the rule here to the left, they give you an example in the middle, and then just sort of a proof, if you had it all expanded, why these rules work. And the truth is when you write it all out, exponents are just a shorter way of writing a bunch of multiplication problems out. And so that's why they exist. So when you're multiplying exponents that have the same base, you can just copy the base, add the powers. Things you already know. When you're dividing exponents and the bases are the same, you can copy the base and subtract the numerator minus the denominator. Okay? When you have a power to a power, copy the base, multiply the powers. You guys know this one. If you had Mr. Shuda, he talked about powers in the sky, you multiply, if you remember that. When you have multiple things being multiplied together, all raised to a power, it's the same as raising each of them to that power. It's kind of distributive property-ish, but you're making sure that everything gets raised to that power. And then the same thing is true if you have a fraction raised to a power, that both parts get raised to that power. Okay? Nothing new there. Just review of those power rules that you need to know, and should be in good shape there. Questions about any of that? Again, it's on page 21. If you want to grab it and put it in your notes, that's up to you. There are a couple definitions that we need to talk about. Specifically, any number raised to the 0 power is 1. And this is on page 19 in your book. Any number raised to the 0 power always equals 1. The only conversation or debate you could ever have is 0 to the 0 power equal 1? And we just aren't going to talk about that. Which is why when you see something over here like this, x cannot equal 0, obviously that makes this all 0, and 0 to the 0, does that 1 or is that 0? And that's the great debate that we will not engage in. The other issue that we have is when you have a base raised to a negative power. It has nothing to do with negative numbers. Okay? All it has to do with is position in relationship to the fraction bar. See that right now the fraction bar is here, right? Because it could be b to the negative n over 1. All we've got to do, and hopefully you remember this, you take this, slide it across, and it becomes positive, and that leaves me a 1 up top, and that's where the definition comes from. The negative power, if you move it across the fraction bar, either direction will change the sign of the power. And this is stuff we covered in Algebra 2. Some of you who did pre-calc last year probably covered this, but you definitely covered this in Algebra 2. Okay? Any questions about any of that? Next, examples. Scientific notation. And this particular table is on page 22. And there are some very specific things about scientific notation. And I know you guys have to do this stuff in science class or have done it in science class, but I want to be sure that we're all on the same page here. Okay? Here's what's really important. This right here, let's get a different color. Let's go, no, I want the bright green. This is scientific notation form. A times 10 to some power. A has to be between, so it has to be greater than or equal to 1, and less than 10. Basically, it's a one-digit unit. Okay, except you can have decimals. So you can have anything from 1 point something all the way up to 9 point something. So there's only ever one digit to the left of the decimal. That's scientific notation. If it's got to be between basically 1 point, it has to be between 1 and 9.99999. Okay? It can't equal 10 because then that's two digits to the left of the decimal. It can't be less than 1 because then there's a 0 to the left of the decimal. Okay? So notice over here, we've got lots of different examples. You've got 2.6. You don't need to put all the zeros because it's understood. Over here, 5.0. Now here's why that's important, because we don't know if there are other digits there because it's such a small number. It's probably rounded at some point. Okay, so we put it when it's a whole number. We don't put the decimals, but when it's an actual decimal to start with, we keep that final decimal. Now let's talk about how to get to this. You're basically taking the decimal point, and again, I know you know this, but I'm going to review it anyway, and you move it all the way over till there's only one digit to the left of the decimal. So in this case, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, and there's only one digit to the left of the decimal. That's where that 9 comes from. Okay, and the way I like to think about scientific notation is that if the power is positive, it's a quote-unquote big number. And to me, when I talk about scientific notation, the big number is greater than 0. I'm sorry, greater than 1. Yep, greater than 1. Okay, a quote-unquote small number is where I'm going to get the negative. I know some of you go, if you move it to the left, it's positive. You move it to the right, it's negative. I mean, you can think about it that way, that's fine. But initially, I look at this and I go, obviously, this is a big number, but this is a small number because it's less than 1. So where I go here is I go 1, 2, 3, 4, 5, 6 places. And since it was a small number to begin with, my power should be negative. That's the way I like to think about it instead of thinking right or left. Okay, how you choose to think about it is up to you, but that would be my suggestion. Okay. Again, you guys know about scientific notation. We're going to go through some examples now. Okay, these are in your book. I can't tell you what page they're on. I don't know. But if you want to write them down or if you want to take a picture, try doing these 3 and let's see how you do. And then we'll go from there. On this first one here, what is being raised to the 0 power? Z. Just z. The 4 is not being raised to the 0 power. So what is z to the 0 power? 1. Okay, so really this is just 4 times 1, which is 4. How many had that one correct? Okay, good. Now this case, everything's being raised to the 0 power. Anything to the 0 power is 1. Piece of cake. So here's where we're talking about that problem from before, from the homework, right? Is the negative being raised to the 0 power? No. It is not. So again, here's how I like to think about this. The negative is over here. The 4 is being raised to the 0 power, and that is 1, so C is negative 1. How many had all 3 of those right? Okay. If you didn't, do you know why? You figured it out? You good? Questions? Ray, you good? You look a little confused to me right now. No, you're fine. Okay, cool. All right, next group. So now we get to a little more complicated. Some negative powers. Remember, what simplify means in this case is get rid of the negative powers. And if you have numbers, simplify them as much as you can. Okay, so take a few minutes to do those 3, and we'll see how you did. All right, so on this first one, again, here's what we have to do. We have a negative power. We can't evaluate until we get rid of the negative power, so the whole thing has to basically move down. All right, and what's 2 to the 3rd when it goes to the bottom? 8 goes on the bottom. What's on top? 1/8. So my answer is 1/8. Again, this goes down. So then I have an 8 down there with a 1 on the top. That's where that comes from. Any questions on that? Okay, so what happens on the second one? What has to change? This one has to go up, right? And so when it goes up, it just changes to n to the 5th. Well, what's on the bottom? 1. So what's n to the 5th over 1? N to the 5th. Okay, that goes up. All right, what has to move on the last one? Yep, just b to the -9. Everything else is okay. That has to go down. So this stays put. That stays on the top. Okay. So I get -3a to the 4th over b to the 9th. I'm going to write all that in. That goes up. That goes down. Okay. Any questions about any of that? Stretching or question?
What?
Stretching? Okay, good. Next. Let's make it a little harder. Okay. Write the answer with positive exponents only. So now we're going to combine a bunch of those exponent rules. Okay, on this first one, you should get a final numerical answer because it's all number bases. So you should be able to get a final answer. And then these ones take a little bit of time. So give those a shot, and I'll give you a little extra time for these. So a couple things going on here. You can raise both of these to the -2, or you can actually flip it and then just raise them to the second. One thing you can do. So here are the things that I did. Okay. Raise both of them to the -2. This 4 just goes down, 4 to the +1 now. So it goes down, and of course 9 to the 0 is 1. Now what has to happen is these basically switch positions. So I get 3 squared on top, which is 9 on top, 2 squared on the bottom, 4. So really what I have is 9/4 minus 1/4 plus 1. Well, what is 9/4 minus 1/4? 8/4, which is 2 plus 1 is? Okay. How many had that correct? Very good. All right, next one. The whole 3 to the w, or 3w, has to be raised to the -3rd, and it has to go down. Here we're going to raise 5 to the 2nd. Don't forget about the 5 to the 2nd. Sometimes you forget that. W to the 2nd and t to the 10th. So here I have it written out. Okay, so 3 to the 3rd on the bottom, w to the 3rd on the bottom, 5 squared is 25, w squared is w squared, t to the 5th to the 2nd is t to the 10th. Okay, then I bring them together and I can cancel. I can do some reducing. I can find out what 3 to the 3rd is, right? That's what? 27, and that doesn't reduce to 25, but w to the 3rd and w to the 2nd can reduce. Okay, I'm going to bring them together first, but where are there more w's, on top or bottom? Bottom. So how many more w's? 1 more on the bottom. So my final answer should be 25 t to the 10th over 27w. How many had that one? Okay, good. So again, all I did here is I canceled, and then that went away. Okay. So there's a lot of steps, right? You got to be careful. Take your time. Step by step. All right, now this one's trickier. I have to raise all of this stuff to the -3, but what would make this easier first? Absolutely. Subtract powers, reduce. So be careful here too. Some of you will want to subtract. You get in the habit with these powers and you're subtracting powers that have the same base, and then you forget how to work a regular fraction. It's not 13, right? 26 over 13 is what? 2. So be careful. I would absolutely reduce on the inside before you try to do anything. So this gives me 2. C to the 5th over c, c to the 4th on top. Now, the one thing I would say that maybe is confusing, but it doesn't have to be, -2 minus 8 is -10. Or you can just take it and move it down with the d to the 8th, and that's where the d to the 10th comes from. Because that d to the -2 goes down, makes it d to the 2nd. d to the second times d to the eighth is d to the 10th. Now I can raise all of it to the negative 3 power. So here's what that looks like. Now, if you raised everything to the negative 3 power to begin with, you could still get the same answer. The problem will come in when you deal with 26 to the third and 13 to the third and trying to reduce that, and that's kind of nightmarish. So whenever you can make your numbers a little bit smaller to begin with, it's going to make it easier for you to do the problems without using a calculator, which typically means you'll be able to do them a little more quickly. Okay, so now all three of these have to move. This has to go up, this has to go down, this has to go down. Okay, so the d to negative 30, that goes to the top, becomes d to the 30. 2 to the negative 3, that goes down, so 2 to the third on the bottom is an 8. c to the negative 12 goes down, and that's it down there. Okay. Anybody have all three of those right? Good. 2 out of 3. All right. If you only got one right, and make sure you know what you did wrong. Don't just sit on it. Okay, make sure you do something about it if necessary. Okay. Can I go to the next slide?
No.
Okay. All I'm trying to do is get you to take those numbers and change them to scientific notation. Okay, so all the wording and all that stuff is just giving it context, but the truth is we're just practicing taking those numbers in those problems and putting them in scientific notation. Let me do this because that'll be easier for you to figure out what numbers you're trying to convert. So there are the three numbers that I'm asking you to convert into scientific notation. So do that, please. Question?
Can you do 10 to the 0? That doesn't make sense.
So if it has to be in scientific notation, you have to have the a, that number that only has one digit to the left of the decimal, and times 10 to something. So yeah, in this case, that's what you're going to end up doing, right?
Wait, how long are we not